Hello, my fellow scientists. We are back again at tackling math and science with me, your favorite Sensei Mohab. So, on today's lesson, we're gonna be dealing with NSC past paper question 8 on calculus. So, if you are new to our family, please press that subscribe button down there below and also hit that notification bell so that every time we post a new lesson you may be up to date and you'll be able to know all the new lessons that we post. And for inquiries, if you want me to be a personal tutor, you can WhatsApp me at 081-537-9527. It's my WhatsApp number, and the email is in the bio. It's mohau09@gmail.com. It's mohau with an H, Musa, NXUSA 09@gmail.com. So let's begin. So now our question says, the graph, which is the first derivative, y, which is f of x, okay, f prime x, which is the first derivative, it's mx squared plus nx plus k is drawn below this one. So the graph passes the points p, which is -1/3 is to 0 is this one, and q 1 is to 0, and these two are what? Very good, the x-intercepts. And we also have r 0 is to 1, which is the y-intercept. So now question says, determine the values of m, n, and k. So this is how we're gonna do it. So you can pause the video and just practice with this because it's from a past paper. Just practice with this, and then thereafter you will get the memo of this and you will be able to know, alright, do you know, do you understand calculus to this point, or you have to revise it again and again? So because practice makes perfect. So we are given mx squared plus nx plus k. So the first thing that we will be able to find, very good, is our k, because we know that k here is a constant, which is in a way it's our y-intercept, because if everything is, because we know the y-intercept is 0, the x coordinate. So if it's 0, it's 0, then this will be 0, and we'll be left with this one, which will be the y-intercept, which will be 1. So now, how do we find the m? So our m here is the gradient, and a is positive. So now, since our a is positive here because of the graph, we will just do it like this so that we can be able to find our a. So you can use this equation, x minus x2. So can you know that x1 and x2 are the axes of the intercepts, the x-intercepts, and here we'll be using the y-intercept. So now we substitute all our coordinates. So 1 and 0, it's negative 1 over 1/3 is to 0, and r 1 0 sorry 0 is to 1. So it will be x minus 1 and x minus into minus 1 over root 3. So now, because we are looking for our a, so we can just substitute each and everything we have. So we have what again? We have our y-intercept, this one. So we know that y-intercept, our x, will be 0. So it will be 0 minus 1, 0 minus into minus 1/3. Let me just do positive here, because we know that negative multiplied by negative will be a positive. So now it will be, oh sorry, we're supposed to do the y coordinate there. So it's 1, it's negative 1 multiplied by positive 1 over 3, which when we multiply those two, they are going to give us negative 1 over 3, a and 1. So since we are looking for our a, what do? We can just multiply both sides with this inverse here, or you can just divide, say 1 divide by negative 3, just like that. So it will be negative 3, our a. So many of y'all may wonder, why is our a negative when the graph is, oh sorry, it's a sad graph. Oh yeah, I made a mistake here, sorry for that. It's a sad graph, so that's why our a needs to be negative. Sorry, I made a mistake there. So but you understand, a is negative, so in a way our a is similar to our m in a way. So instead of writing a, we should have just used m, but it's not a train smash, as long as at the end you just pointed out that a is equals to m is equals to negative 3. So now we have 2 now. So now we need to find our n, which is this one. So kindly note, because we are dealing with trinomials, it's something like this. Let's say it's 2 plus 2 and 2 plus 2, and we're gonna factorize it. It's gonna be x squared plus 2x plus 2x plus 4, which will be left with 4x plus 4x squared. So we are looking for this. So you can see that we can find it by just doing this binomials in one brackets and just factorizing it. We will be able to find the value of n. So we're going to substitute everything that we have, our m and also the k. So it's going to be like this. We can just use this one. It will be negative 3 minus, I'm just going to go straight to the point, and x minus 1 over root 3. So now remember, we have to factorize everything that is here first, then after factorizing, that's when we will be able to multiply with this negative 3, that is outside. So negative x times x is x squared. Then here, okay, let me just do it like this, and just we'll deal with the sign later. Negative 3, x and x, it's x squared. X times x is plus 1 over 3 x minus x minus 1 over 3. So now we have like terms here and here. It will be 1 over 3 minus 1. Our answer will be left with negative 2 over 3 x minus 1 over 3. Then now we can multiply with this one. It will be negative 3x squared. Negative 3 multiplied by this, it will just be negative. It will be positive 2. Positive 2x, and this will be positive 1, because this and this will cancel out. And this is our equation. So therefore we now know that our n is equals to 2. This is how we tackle this. So I don't have enough space there. Okay, let me take out another page. So now question 2 says, if it is further given that f of x, it's another graph, minus 3x minus x to the power 3 plus x squared plus x plus 2, it's a calculus, determine the coordinates of the turning point. So how do we find the turning point? We do the first derivative for the x value, then for the y value we substitute into the original equation. So which means we must do the derivative of this. We must derive this we can do it using this method. Some of y'all can just say it's this reference mesh. You can use this. So it's n, which is 3 negative x to the power 2, because it's 3 minus 1. It's 3 minus 1 plus 2x, and it's 1. 2 minus 1, it will give us 1 plus 1, because of we know it will be like this, which it will just give us x to the power 0, which is 1, just like that. And we can see that this is the same as what we found in the previous question. This, see, so now there's no need for us to even try to factorize this, because we know that the x values or the factors are the same. So we know that the factors here are gonna be x minus 1 and x plus 3. So now we know that it will be x and 1, which are these points here. X will give us 1, and this will give us, oh sorry, not these points, but then this x values here and here, and will be negative 1 over 3. So we have the x values. Now we substitute into the original equation to find the y values. Let's do it here. Minus 1 to the power 3 plus 1 squared, which is -1, then 1 should give us 0, plus 1 plus 2 gives us 3. Yeah, and x, I'm just gonna put it inside brackets because it's a negative 1/3. It's 2, it's negative 1/3, it's negative 1/3 squared, it's plus, okay, yeah, everything is correct. It's 49/27, which is 1,81 units. Just gonna leave it in those 2 decimals. Yeah, rounded off, it will just give us 1,82. So now we have this coordinates. We know it's 1. Yeah, we need to write it in this format as coordinates, unless if maybe they said that write the x value of the turning points, then we just leave it like that. So now question 3 says draw the graph of f. Indicate on your graph coordinates of the turning point, the intercepts, and the x's. So now our turning points, let's start with them. It's 1 is to 3. Yeah, I did a very short graph, apologies for that. And -1/1,82, which will be somewhere here. And we know because it's -a, our graph will be like this. From up, it will go down. So since here they're not looking for any concavity that we need to show, the points of inflection, there's no need for us to do them. We just obeying the instructions. So we know that x-intercepts will be here. So our graph will go like this. It will be like here and here and going onward. So now we have to find our x-intercepts and y-intercepts. So now we need to find the x-intercept. So but since you can see our graph, it's the turning point, it's a bit upwards, which means that we will only have only one turning point. Oh, sorry, only one x-intercept. So now let's try to find our factors. Let's just use 1. Oh, but no, 1 is just here. So let's try 2 or 3. 2, it's plus 2 to the power 2 plus 2 plus 2. 2 plus 2. Oh, 2. 2. Okay, oh, this one is for the y-intercept. So it's 0. So, which means that our other x-intercept is 2. Which is here. Can see x-intercept is 2. So now let's try to do another question. So now here the question says, determine the value of A. So it says E and W points are two variable points on the same horizontal line. So remember this. You probably have done this, or maybe some of you all maybe forgot this. In grade 10, when you were first started taught, you were taught for the first time base angles of an isosceles triangle. These two angles here, we call them variable points because they are on the same horizontal line. So if now say point E and W are on the same variable point on the same horizontal line, whereby H is a tangent at E and G is a tangent at W. So now, which means that it's either, I'm just gonna do it here. It's like this triangle, like this, whereby this and this are the variable points. So now, point E and W are the variable points on, the same variable points. H is a tangent at F, and E, the tangent at W. H and G intersect at D. So now here we know that we will have our D. So yeah, I will just put E and W here. So now, if now they say that E and W are the variable points, we can say that it's like they're in the same length. Okay, let me just draw a smaller isosceles angle. You know that if something is variable point, which means that this angle and this angle are equal, and also the sides are the same, which means because of now if the two sides are equal, then now we can just do half of this. It will be the same side here and the same sides here. In a way, it will be like us solving for congruency. So now we know that it's gonna be like this. So we can try to find this angle here by using the midpoint. So we can use the midpoint. It's gonna be for A, we can use the midpoint. It will be minus 1 over 3 plus 1 over 2 will give us negative 1 over 3 plus 1, no, plus 1 divided by 2 will give us 1 over 3, which means it's somewhere here. So now, or we can use this. So now, first we used the midpoint because we know that it's gonna be like the half of this distance because these angles are on the same horizontal lines, so we can also try to do this. Try to find the turning point here, and we know that for the turning point it's x is minus b over 2a, and from here y use the turning point? Many of you all may ask. We using the turning point because since we know that E and W are variable points, we know that the shape is going to be something like this, an isosceles triangle, which we know that if, let's say, we have an isosceles triangle here, you can see that it's the tip here, or the apex, it's there at the turning point, even though I didn't draw it up to scale, but it's there at the turning point. So that's why we using that, because of it's gonna take that x value of the turning point. So it's minus b, it's b 2 over 2a, it's negative 3. So it's going to give us negative 2 over negative 6. It's this and this will cancel out, will be a positive, and we're going to have 1 over 3, the same answer. So now for our last question says, determine the values of b for which h and b will no longer be tangents. So since we know that here this and this h and g met here, which was the 2 points where they meet, the point of intersection. But now we're no longer going to use that, because they say they will no longer be equal tangents to f. So now we can try to substitute this into the original equation. So when we punch this value of the turning point, the value of a, it will into this original equation, it will just give us 4 over 3. 4 over 3 is the turning point. But since they say that for which h and g will no longer be tangents to f, so it must be less than 4 over 3. It must be a bit upwards, less than 4 over 3. So yeah, that's how we tackle this. Thank you.